talk about how to determine the range of an exponential function. So remember we talked about domain and range. Domain is all the possible x values of a function. Range is all the possible y values. So the range of an exponential function will be determined by the horizontal asymptote. So if a is bigger than 0, the range will be all the y values that are above the horizontal asymptote. If a is less than 0, the range will be all the y values that are below the horizontal asymptote. So the horizontal asymptotes of exponential functions, remember, you can figure out based on the form of the equation. So if it's in y equals ab to the x form, the horizontal asymptote is the x-axis, right, which is y equals 0. And if you think about it, it makes sense because, here we say if it's in y equals ab to the x plus k form, the horizontal asymptote is y equals k. Well, it makes sense because if you're in y equals ab to the x form, like your k is basically 0, right? So that's why y equals 0 is the horizontal asymptote. So when we talk about the range of a function, that's in the form y equals ab to the x. When a is bigger than 0, notice that it's going to be all y values that are greater than 0, right? So it's going to be all positive numbers because we have a horizontal asymptote at y equals 0, and then all the y values are going to be above that. If a is negative, it's going to be the opposite situation, right? So the horizontal asymptote, once again, is at y equals 0, but then since a is negative, all the range values are going to be below that, okay? So you can see when we have a -4, it's going to be all below 0. So if we have an ab to the x plus k situation, remember k is going to tell us the horizontal asymptote, and then if a is positive, all the range values are going to be above the horizontal asymptote. So if we have 2 times 3 to the x minus 1, the horizontal asymptote will be at y equals -1. Since a is positive, all the range values are going to be above y equals -1. So the range will go from -1 to infinity. Remember that the -1, you need to put an open parentheses there because it's not included, because that's a value that the function is going to approach, but it's not actually going to equal. So similarly, if we have y equals ab to the x plus k, where a is less than 0, it's going to be all the range values that are less than the horizontal asymptote. Okay, so that k is going to tell us we have a horizontal asymptote at y equals 2, and then notice that a is negative. Okay, so since a is negative, it's going to be all y values that are less than 2. So when we describe the range, we're going to say it's going to go from -infinity, right, because that's the lowest value, to the highest value, which is 2. Once again, remember that the 2 is not included. So let's determine the range of the function, -3 times 1/4 to the -x plus 5. So one thing to notice here is that it has to be in one of our forms, okay? So it has to be in y equals ab to the x form, or it has to be in y equals ab to the x plus k form. So it's very important to notice that in both these forms, like x is by itself, okay? Notice what's wrong here is that we have a -x. So what we need to do is we need to rewrite this function a little bit. We have g of x equals -3, and then that 1/4, I'm going to put that to the -1 and then raise that to the x power. Okay, so I just kind of broke that down using that power property, where if you have a power to a power, you multiply the exponent. So all I did was I took -x and I rewrote that as -1 times x. So then we still have that plus 5. Well, let's think about this. We have 1/4 to the -1. Remember that raising anything to the -1 power is like taking the reciprocal. So if I think about 1/4 and I think about the reciprocal of it, the reciprocal of 1/4 is just 4. So this is -3 times 4 to the x plus 5. Okay, so I just wanted to rewrite that function so that it's in the correct form. So notice that this is in y equals ab to the x plus k form. So we know that k, which is 5, is going to tell us we have a horizontal asymptote at y equals 5. Okay, so we have it at y equals 5, and then notice that a is negative, right? So a is less than 0, so that means that the range is going to be all values of y that are less than 5. So the way we write that in interval notation is we're going to say it's going to go from -infinity to 5. Okay, so that's how we describe the range of this function. So just always make sure that your function's in the correct form before you start looking at all of the values that are included. So now let's determine the range of the function g of x equals 4 times 0.5 to the negative x minus 2. Well, once again, this is not in the right form, right? So we want this to be in y equals ab to the x plus k form, but I have that negative x going on again. So I'm just going to rewrite it. So I have g of x equals 4 times 0.5 to the negative 1, and then that's raised to the x power, and then minus 2. So we have 4 times 0.5 to the negative 1. So that's like the reciprocal of 0.5. 0.5, if you remember, that is 1/2. So the reciprocal of 1/2 is just going to be 2. So that's 2 to the x minus 2. And so now my function is in the correct form. So k, which is negative 2, is going to tell me that I have a horizontal asymptote here at y equals negative 2. Well, my value of a is greater than 0, right? So that means all my y values are going to be above negative 2. So the way I would describe the range is I would say the range goes from negative 2 to positive infinity. So now you can pause the video and try this example on your own. So in this function we have, it is in the form y equals ab to the x. Okay, so functions in that form, remember that basically means k is 0. So my horizontal asymptote is going to be at y equals 0. So now it's a question of a. So a in this case is 2, which is greater than 0. So that means that my range is going to be all y values that are greater than 0. So the way to write that in interval notation is you would say it goes from 0 to positive infinity. Okay, so that is the range of this exponential function. So remember that by looking at the equation of an exponential function, you can determine the horizontal asymptote. If it's in y equals ab to the x form, the horizontal asymptote is the x-axis, which is y equals 0. If it's in the form y equals ab to the x plus k, the horizontal asymptote is the line y equals k. If a is positive, the range will be all y values greater than the horizontal asymptote. If a is negative, the range will be all y values less than the horizontal asymptote.